All right, so that's that circle, that size of that circle, the radius of 1, is inside this set of basically that small square, right? Okay, so everything that we're still in the coordinate plane here. Okay, I just want you guys to understand that everything we're doing, we're not worried about things out to 10 and 11 and 12 and in the coordinate plane like we've been doing a lot in college algebra. We're zoomed in and we're focused solely on that circle that exists inside that square. Is that right? Okay. So there are ordered pairs for that point B, right? Would you agree with that? As we look at B rotating around here, let me just actually put the circle in. Okay. B is going to move around that circle. Okay. And it's going to change its ordered pair all the time, right? But the ordered pair of that circle, because we don't get outside the values of 1 in any direction, right? So a lot of these values, a lot of these ordered pairs you see over here are kind of ugly ordered pairs, aren't they? Okay. But we're going to kind of work to see if we can develop any not so ugly ordered pairs. Okay. So that's the unit circle. That's the thing that we're going to kind of deal with the most in this class. So what I want to kind of deal with and look at is maybe looking at point B. Looking at point B. And I want to come up with an equation for the unit circle first. Okay, and this is something that we've done in the past. You guys have learned, we did this in geometry, we did it at the beginning of college algebra, that every single circle is going to be of the form, you even did this in algebra 2 with conic sections, it's going to be in the form of that, right? X minus h squared plus y minus k squared equals r squared, where h and k are your center, correct? Well, I'm interested in the unit circle. The unit circle has a center where? 0, 0. So that number goes to 0, that number goes to 0, and it leaves me essentially x squared plus y squared. And the radius is what? 1, so 1 squared. So what that tells me is that every single point B, no matter where I move it, in this case the 0.7, 0.71, okay, wherever I take those x values and square, and then take the y value and square, and add it together, it should evaluate to 1. Does that make sense? Okay. So I'm going to show you that with GeoGebra and how basically it compares to what we're going to do by hand with some of these questions here in a moment. I'm going to take the x value from B. So the way I do that with GeoGebra is I just hit the x key, and then I have to put in parentheses that I'm going to look at B. Okay, so that's recalling the x value from point B. I'm going to square that. So that's essentially just saying x squared, right? Does that make sense? For that specific B. And then I'm going to add to it y of B. And I'm going to square that. One too many unnecessary parentheses there. And I want to hit enter. And you see the number that spit back here was 1, right? So it was taking, now here's the thing, my rounding is, you go out to 15 decimal places, that's the ordered pair that was really getting placed inside this formula here. Does that make sense? Okay. But and that's only 15 decimal places. Chances are that's probably an irrational number. Okay? That's probably an irrational number. But plugged into here, add together, I get 1. And as I move that point B around, you see that those ordered pairs change, right? Okay, but does that number 1 right here ever change? No. Okay. Okay? So what it's doing is it's taking all those respective points that are changing as I move around, plugging them, squaring them, adding them together, and you always get 1. And that should be something that we understand algebraically about satisfying equations, right? If you want to satisfy an equation, you're going to take values of x and y, plug them in, and see if you get a true statement. That means you satisfy the equation, and we do here. Okay. Now, when you're asked to do this in homework, a lot of times they don't give you ugly numbers like those decimals. They're going to give you things like this. Okay. They're going to say show that point P, which is radical 3 over 3, comma radical 6 over 3 is on the unit circle. So if I think about that, those are both positive numbers, right? And radical 3 is a smaller number than radical 6, isn't it? So this number here is probably like right there. I would assume maybe P, both positive, right? And the x value is smaller than the y value. So it'd be on the circle, it'd be there. I want to make sure that it is on the unit circle. So what I want to do is I want to take my x squared plus y squared is equal to 1. This being your x value, that being your y value. And now I'm just going to see if it satisfies the equation. So I'm going to take radical 3 over 3, square it. Radical 6 over 3, square it. See if that gives me my 1. What's radical 3 squared? 3. And what's 3 squared? 9. What's radical 6 squared? 6. And what's 3 squared? 9. Does that equal 1? Yep. Okay. So a lot of times once we prove something, a lot of times the way we conclude it and show people that we're done is that we would make a little box and we shade it in. Just basically says that we've shown what we've been asked to show. Okay. There's a lot of different ways that people conclude proofs. It's kind of an algebraic proof here. A lot of notation that's, as you guys get into other more advanced classes, maybe you start seeing those things. Come back to this here. If I looked at square root of 3, square root of 3 divided by 3, comma, square root of 6 divided by 3. Does that point show up on the circle? Yeah. Okay. There are a lot of similar type questions that they're going to ask. A variety of that is to tell you that you do exist on the unit circle, but you don't know what the y value is, or maybe you don't know what the x value is, and they ask you to find those things. Okay. This question here says the point P is going to be on my unit circle. Okay. The x value is radical 3 over 2, so that tells, because the x value is positive, that tells me I'm either in the first quadrant or the fourth quadrant with that number, right? Okay. But if I look at this, it says my final answer needs to be in the fourth quadrant. So if my final answer is going to be in the fourth quadrant, what should my y value sign be? Should be negative. Okay. So I'm looking in this quadrant, my x values are all positive, my y values are all negative. So it's just something to think about as we do this problem. I have x squared plus y squared equals 1, right? That if P is on the unit circle, it satisfies that condition. And we know it is indeed on the unit circle. So plugging things in, I get radical 3 over 2. Square that plus y squared is equal to 1. Radical 3 squared is 3. 2 squared is, gives me that. So what's y squared going to equal? 1/4. So now that's going to lead to y squared is equal to plus or minus 1/2, right? Take the square root of this. Square root of 1 is 1. Square root of 4 is 2. And you got plus or minus, right? The reason we get plus or minus is because we do have the ability to have a point up here maybe radical 3 over 2 comma 1/2, but then its reflection down here, radical 3 over 2 comma negative 1/2. So that's the idea of where the two values, positive and negative, come from. But which one were we looking for? The negative one, because of the quadrant they told us we needed to be in. Okay. There's a lot of points, guys, that are kind of useful for the unit circle, and I'm just gonna take that one we just found and see if I put in, let's see here, was it square root of 3 over 2 comma negative 1/2, right? Oh, there we go. That point right there, right? And show its name and value. So, whenever you see this, that's radical 3 over 2 right there. Okay. Can I use symmetry with this circle? Is every circle symmetric about its diameters? Yeah. Would you agree that the y-axis is a diameter, or the portion of the y-axis from 1 to negative 1 is a diameter? Same thing for the x-axis, right? So should I be able to take point D and reflect it? Point D, reflect it along that line, and it show up on my circle? Notice that the quantities for the ordered pairs are the same, right? But the x value here is negative because from A to D prime, I need to move left, right? So that's why it's negative, and the y value again is negative. Can I take that point there and reflect it on the x-axis? That gives me that point, right? And I could keep doing this. Can I get those 4 points? But they all have the same ordered pairs, except for the plus or minus aspect of the x and y, right? So every time that we find a point on the unit circle, there are actually 3 other points that have the exact same coordinates, just different pluses or minuses up front, right? And that's something to keep in mind, which is nice because eventually we're going to learn, or try to learn, about 17 of these special points. That is actually one of the special points we're going to learn because of the angle that's associated with it. But I can learn one ordered pair. I can learn that first one in the first quadrant, where they're both positive, radical 3 over 2 comma 1/2. And because I've learned that, I ultimately know 3 others then, right? Okay, and I don't have to memorize 3 others. Usually, kind of show you, I didn't show the last class this, but where we're going with this, the unit circle, we're trying to eventually get to an understanding of this picture here. Will show up. Man. Let me just do this. Unit circle. All right, so this picture here is what we're going to try to learn. And there's a lot of stuff going on in there, right? But if you start looking at that and look at the x and y axis, you can see that you can fold the x and y axis, and a lot of those things are going to land on top of each other, right? Every red ordered pair up there is going to land on top of each other. Okay? Every blue ordered pair is going to kind of land on top of each other. And if we can learn just the ones that are in the first quadrant, and then understand that essentially if I fold on the x-axis and the y-axis, it gives me everything else in the other quadrants, that's going to be really useful to where you can now learn mainly 3 ordered pairs, and it tell you a total of like 17 ordered pairs. Is that all right? So that's going to be nice. That's going to be something we're going to do and talk about through the next couple days. We're going to investigate and kind of try to decipher why maybe these ordered pairs are radical 3 over 2 and 1/2, radical 2 over 2 and radical 2 over 2. And hopefully maybe those are values that you have seen in the past from chapter 5. Those values kind of popped up, right? We've seen 1/2 a lot. We've seen radical 2 over 2 a lot because of what kind of triangles? So it's an S, special right triangle, okay? That'll be one aspect that we use to look at and find why those ordered pairs are radical 2 over 2, radical 2 over 2, and so forth. And maybe we'll use system equations as well to show the same exact thing. But that's where we're going to go tomorrow with this. But eventually, that thing right there is going to be your best friend, which is good, Zach, because now you'll have one. It becomes the foundation for the rest of the text, okay, and the rest of the course. Those of you that are physics, maybe have you dealt with any of this in physics, unit circle at all? All right, so it is something that can be a component of the physics course as well. Have a fantastic rest of the day.
You as well.
Thank you. What? You want everybody to know? Everybody knew already.
What? Well, shoot. Shoot.